All right, gentlemen, I'll be right with you. Just finalizing, everything. Zoom, done. Let's see. Share my screen. Start the broadcast. All right. All right. Let me just log in here real quick. Zoom. Go. Join. All right. Okay. Testing. Mic check. 1, 2, 1, 2. Okay. So I know that's working. All right, gentlemen. Welcome. Sorry for the delay. The delay comes. Let me see. So I did the best I could to update your grades in Blackboard. It's not like 100% accurate, but at least it should be showing like your grades from Pearson, right? So I was trying something a little bit different. Normally I export and do it manually in numbers and then upload that file. So I guess like Blackboard and Pearson have like updated their stuff where it does seem like it syncs. Um, there's still something on my end that I have to do to get it to work 100%. So I say this to say it's a good idea to check your grades for accuracy in Blackboard. Um, yeah, you know, and this isn't 100% accurate. This is close. Um, you know, the grades throughout the semester along the way, they're just really feedback. So as long as it's close, it's okay. The only one that really counts, which I'm going to make sure, like even if I have to just like force it and do it manually, is the final grade. But along the way, as long as like those grades are posting, like whatever score you're getting in Pearson is showing up in Blackboard. That's the main thing that we need. And then basically we're just trying to collect this data. You know, the only one that really matters is at the final. So as long as those grades are posting, that's the first level. Let's get to the end of the semester, and then we'll make sure everything. I'm going to make sure that all the numbers crunch properly. But like for instance, the midterm, like part of the challenge is, you know, your lab grade. I think I got it right. Again, I'm trying to use their system. The main thing that you all need right now is that whatever score you're getting on my math lab is showing up in Blackboard. It's supposed to be like an automatic sync, but I noticed some like inconsistencies. So that was part of the reason I was late. I was trying to like get those to work. And I think I got something working. So again, just check your grade. Um, if anything is missing or if it looks out of order, just bring it to my attention and we can try to make sure that things are posted. I did have to go through manually and like update some students' grades because for whatever reason it wouldn't post um, for like at least one assignment. So again, so along the way, so you don't have to stress out too much about it. Like for right now, along the way, this is just feedback so that you can get a sense of what I see on my end. All right. So then you check it. If it looks okay, you're fine. If you recognize something that you're missing, say, hey, Professor Pfeiffer, I was reviewing my grade. I did this assignment. Here's the screenshot with proof showing that I did it, but in the grade book, it's showing something else. Something like that. And then I look at it. I was like, okay, it's supposed to be an automatic sync and like live updating, but it it seems like it's a little bit off. And I am using my microphone today. So I am monitoring the chat. Uh, Let me see. Chat looks okay, and so I'm monitoring the chat and Q&A, and I will do audio at the end. Uh, so hopefully everyone had a good weekend. And then like one other thing with the grade. So there's about, let me see, homework, quizzes, exams in the lab. There are like four different categories that I try to like incorporate into your overall grade. It's a running total, so like as you update assignments, it should change. And like if we didn't have a lab, the homework would be 10%, the quizzes would be 10%, and the exams would be 60%. So notice that those don't add up to 100% because we haven't taken the final. So that's part of it. It's not an official grade. It's just feedback on where you are. Like what I'm just it's just feedback to show you, hey, I have a record of this assignment. This is the score that I have, and we're working a running total for the overall score. You don't really get an accurate overall score until the final exam is submitted, right? Because if the final is missing, then we don't have all the different components, if that makes sense, right? So the main thing again is that as long as your scores for your assignments are showing properly, that's the main thing. It's not going to be 100% accurate until we get to the end of the semester. Um, so again, like if we didn't have the lab, homework would be 10, quizzes would be 10, and exams would be 60. So I scaled it so that I did try to include your lab grade, whatever score we had as of this morning. So then that, basically it kind of boils down to homework is like 9% of your overall grade. Quizzes are 9% of your overall grade. The exams ended up being like 54% of your overall grade. And then I left the lab as 10% of your overall grade. So that's how I did the grading. So, again, the main thing is that as long as you can see your scores and it's close, then that's fine. It's not going to be 100% accurate until the end of the semester after we take the final. Oh, it's okay. It's okay. Yeah, you're good. I'm just still kind of doing morning announcements. Uh, Long story short, I updated grades as best I could in Blackboard. The scores the calculation might be a little bit different, but your scores for each assignment should match the scores that's in Pearson. So just you definitely want to check that for accuracy. If you're missing anything, or if you've completed something and is not posting, take a screenshot, just message me, and we'll make sure that it posts. Okay. So that's the long and short and the nitty gritty of that. So today we're just going with the next installment. So you kind of I mean, hopefully you're picking up on the rhythm from here on out. I think this is like the fifth assignment or the fifth set of new information. So like today we're going to be working on section 1.5. And then on Wednesday, we'll do as many of the corresponding homework questions with the section as we can. Next week is 1.6. And then the week after that will be exam 2, right? And so like we don't really have a midterm exam. I'll just calculate your midterm grade based on whatever's been due up until that point in time, right? Okay. All right, so let's get the party started. So section 1.5 are transformations of functions. I think last time with section 1.4 we had a library of functions. So that's where we kind of explored or introduced, the baseline collection of main different types of functions that we'll have when we're doing graphing. So last time I know we talked about like the constant function, the identity function, the squaring function, cubing function, absolute value function. I know at one point we talked about a step function. We talked about a cubing function, square root function. Those are the main ones. I know I think we mentioned also the reciprocal function. So those are the main ones off the top of my head I can think of. There might be a few more in there. But yeah, those serve as like a baseline of different functions we're going to start manipulating to graph. And like one of the first ways that we talked about graphing was basically creating points, plotting points, and if it's a line, you connect it with a straight edge. If it's a curve, you connect the points with a smooth curve. Okay. So now that we're going to take those base functions and start to apply transformations on the functions, I'll go ahead and give you a little bit of a brief overview. There are a total of 10 transformations altogether. So with these transformations, I feel like each transformation in and of itself is simple, but the challenge comes in basically processing information overload. It's like a lot of like minute information. So each packet of information by itself is simple, but then when you put it all together, I know students tend to experience information overload. The only way I know to kind of combat that is through practice, repetition, and exposure. So you have to kind of like start as early as possible and just keep trying, and eventually it will sink in. But if you procrastinate on something like this, then now you're kind of backing yourself into a corner that it's not going to serve you, right? It's you're going to be kind of like wasting your time if you procrastinate. So be leery about procrastination when it comes to this kind of stuff. It's the topics are simple, but it is information overload, right? So you want to give yourself as much time to let this information marinate and sink in. So we have a few objectives here. One, define transformations of graphs. Two, use vertical or horizontal shifts to graph functions. Three, use reflections to graph functions. And then four, use stretching or compressing to graph functions. Yeah, that's a pretty decent summary of the 10 transformations we're about to go through. Okay. So transformations, if a new function is formed by performing certain operations on a given function f, then the graph of the new function is called a transformation of the graph of f. So for instance, in this example, let f of x be the absolute value of x, right? Remember last time, absolute value, I think that basic shape is like a V, where the vertex is at the origin. So then we also want to consider the function g of x, which is going to be the absolute value of x plus 2, and h of x, which is the absolute value of x minus 3. We're asked to sketch the graph of these functions on the same coordinate plane and describe how the graphs of g and h relates to the graph of f. So with our library function or our base function, I also mentioned you'll hear me refer to these as parent functions. The parent function here is absolute value of x, right? That's a v, basically is a v where the vertex is at the origin. So we want to see how do these transformations where we add a positive number on the outside of our base function, or if we subtract a positive number on the outside of our basic function, right? Notice I'm stressing the word outside. Outside. So these two manipulations are out. These are manipulations that are outside of our base function, right? So let's see how these are going to affect the graph. So I'm going to piggyback off of my prepared notes here. I felt like I just said a tongue twister. Peter Piper picked a pack of pickled peppers. If Peter Piper picked a pack of pickled peppers, how many pack of pickled peppers did Peter Piper pick? That was kind of okay. I stuttered a little bit. Anyway, okay. Let's see. Right. Okay. So one technique that we can use here for graphing is basically plotting points. Choose several values of x, find the corresponding y, plot the ordered pairs, right? So with the absolute value of x, remember absolute value is the positive distance away from zero a number is, right? So we can choose values of x like maybe negative, when x is -4, -3, -2, -1, 0, 1, 2, 3, 4, right? And then plug those in, find the corresponding y, all right? Okay, so let's just use our table, right? Okay, so the parent function is absolute value. So we chose the values of x was -5, -3, -1, 0, 1, 2, 1, 3, 5, right? Absolute value of -5 is +5. Absolute value of -3 is +3. Absolute value of -1 is 1. And then absolute value of a positive number is that number itself. So then we want to compare that to the next function, which is g, where we add 2 to our results, right? So for instance, when x was -5, absolute value of -5 was 5, plus 2 gave us 7, right? So basically, we're going to add 2 to all the results that we got in that middle column, right? So you see the results there. And then we have these graphs, right? So the blue is the graph of absolute value. It's just a V with a vertex at the origin. Notice here, can somebody in the chat describe to me, how would you describe this transformation, right? We added a positive number, we added a +2 on the outside of our base function. How could you describe the red graph from the blue graph? What do we do to the graph, right? What do we do? If we started with the blue and we finished with the red, how could you describe that? Anybody put that in the chat? I'll give you like a few seconds. right? Moved it up on the y-axis, right? Yeah. So yes, that's okay. So that captures the first of the 10 transformations, right? We added a positive number outside our base function, so it caused our original function to move up 2 units, right? So outside manipulations generally cause a vertical change and they follow our intuition, right? So let's see. What do we mean by that? For instance, in the second part, in this example, we said +2 on the outside. In the second part, we said -3 on the outside, right? So if +2 moved it up by 3 units, what would you anticipate if we subtract 3 on the outside? What would you anticipate that how that's going to affect the original graph? If you just had to guess, if you had to just guess and use your intuition, right? It should go down 3 units vertically, right? So let's see, right? Again, using our intuition, adding 2 on the outside causes it to move up. Intuitively, if we subtract 3 on the outside, it should move down. Let's see what happens. So sure enough, right? We have our same values of x. The blue is the same. And then now instead of adding 2 to those middle results, now we're subtracting 3 from those middle results. So that's basically like knocking each y value down by 3. The x values stay the same, so it doesn't move side to side. We're only changing the y value. So that causes the whole graph to move down by 3 units, right? Again, outside manipulations generally cause a vertical change and they follow our intuition. So if outside manipulations cause a vertical change and they follow our intuitions, what do you think happens if we do an inside manipulation? If you had to guess, right? If outside causes vertical, right? Okay, I see left and right on the x-axis, right? So if outside manipulations affect the y value and it causes a vertical change, then we can anticipate inside manipulations to affect the x value and cause a horizontal change. All right. So we're anticipating that inside manipulation should cause a horizontal change. Do you think, and then if you had to guess and use your intuition, should it follow our intuition or should it be the reverse of our intuition if you had to guess? Right. If we do an inside manipulation, would you anticipate? Right. So let's see what happens. So I did get at least one response where somebody said that they're anticipating it to be the reverse of our intuition. Okay. So now we're anticipating for inside manipulations to cause a horizontal change and be the reverse of our intuition. Okay. So let's see. All right. So this is a recap on vertical. So if we take a positive number and add that positive number outside our base function, it's going to shift the original function up that many units. If we subtract a positive number on the outside of our base function, it's going to shift the original function down that many units, right? So outside manipulations affect the y value, causing a vertical change, okay? So then in this example, right, we notice that we're doing inside manipulations, right? It's inside the base function. The base function here is x squared. Can anybody describe to me in the chat what's the general shape of when the highest power is x squared? What's that general shape, right? If absolute value was a v, what's the general shape of this guy? The parent function y equals x squared. A parabola, right? So a parabola is like a U-shaped curve. The vertex is still at the origin, right? So in the previous example, adding or subtracting numbers outside the base function affected the y value. So now doing manipulations inside the base function, notice because that -2 and that +3 are inside the parentheses, it's going to affect the x value, right? It's right there next to the x is going to affect the x value, causing our original function to move side to side. Now, intuitively, we're saying, okay, when we subtracted a number on the outside, it caused it to move down. Intuitively, you might say, oh, well, subtracting a positive number on the inside should move it in a negative direction, right? Let's see what happens. Is that the case or not? All right, let's just see what happens there. Okay, so we chose several values of x. We found the corresponding y, so we're going to get our parabola. And then with that first one, we subtracted 2 from each x, right? So when x was -4, -4 minus 2, sorry. It should be -6. Yeah, that's fine. That's fine. Um, so then negative 6 squared was a positive 36, right? Uh, these y values didn't pick up until we got to like negative 2, right? When x was negative 2 minus 2 was negative 4. So then the answer shifted 2 units going down in the red, right? Okay. So we're gonna plot this in just a moment. Again, intuitively, we might think, oh, well, if we subtract the number on the inside, it should move in the negative direction, which would be to the left, right? So intuitively, we're thinking, oh, the negative 2 on the inside, maybe it'll go left. Let's see what happens. And then if we do a +3 on the inside, we would think, oh, it should move in the positive direction. But obviously, based on my cues, the opposite happened, right? We thought that subtracting a number on the inside would move it in the negative direction, but actually it moved it in the positive direction. So whenever we're doing inside manipulations, it's the reverse of your intuition, right? You almost have to kind of think like, okay, if we're subtracting a 2 on the inside, what value of x is going to make that 0? Well, a positive 2 would make that 0. So we moved it 2 units in the positive x direction, right? Again, inside manipulations cause a horizontal change and are typically the reverse of our intuition. We subtracted a positive on the inside, it actually moved it in the positive direction 2 to the right. We added a positive 3 on the inside, it moved it in the negative direction 3 to the left. And again, one technique that I feel like works fairly well for inside manipulations, you kind of got to ask yourself, what value of x makes that guy 0? Oh, positive 2 makes that 0. So we move that 2 units in the positive x direction. Oh, negative 3 makes the red guy 0. So we moved it 3 units in the negative x direction, right? It's, again, inside manipulations are the reverse of our intuition, right? Okay. So at this point, we've covered 4 of the 10 transformations. Adding a positive on the outside, it caused a vertical change and it followed our intuition. Subtracting a positive on the outside caused a vertical change. It basically moved it down that many units and followed our intuition. Subtracting a positive on the inside caused a horizontal change and was the reverse of our intuition. So we thought it might go to the negative, but it actually went to the positive. And then adding a positive on the inside also caused a horizontal change. And it's the reverse of our intuition. It moved it to the left 3 units, right? Outside is vertical, follows your intuition. Inside is horizontal and is the reverse of your intuition. Okay. So that's 4 of the 10 transformations. Okay. So now, if we go back to that first part, when we added like the 2 or whatever, when we added that positive on the outside, it only affected the y values and it did not affect the x values, right? So then, again, outside manipulations cause a vertical change. So then, what do you think happens if we multiply the outside by a negative, right? If we multiply the outside by a negative, well, that's so if we're multiplying the outside of our base function by a negative, the x values are not going to change, but it's like our y values are going to go from positive y to negative y. So how do you think that's going to affect our image or the shape? If the x values stay the same, but the y values go from positive to negative, anybody find a way to describe that change or that manipulation? Any takers? I'm just curious. Let me say it one more time. So if we multiply the outside of our base function by a negative, the x values are going to stay the same, but our y values are going to go from positive y to negative y, right? All right. Okay. So no takers. That's okay. Let me see. All 3 functions, the function will point the opposite direction in which way? That is correct, but it's a little bit more you gotta add to that. Negative in which direction? Down. There it is. Yeah. Yeah, that's absolutely right? So, like if you think of a parabola, if the x values are staying the same, but the y values are going from positive to negative, then instead of the parabola opening upward, we would anticipate the parabola opening downward, right? So multiplying the outside by a negative should only affect the y values. It should flip it vertically over the x-axis. We're coming to that in just a moment. So all 3 functions are squaring functions. Okay, so g is obtained by replacing x with x minus 2. So for each point x comma y on the graph of f, there will also be a point x plus 2 comma y on the graph of g. The graph of g is the graph of f shifted 2 units to the right. Okay. Okay. Okay, that's fine. All right. So again, I just want you to kind of make note of the opposite play here, right? When we do these manipulations, one way to go about it when we're doing inside manipulations, what value of x makes that 0, and that'll help to like identify which way it's moving. Now, when you do your transformation, you can choose a few test points and make sure that the numbers match up properly to make sure that you moved it in the right direction. Sometimes I have to do that, right? Because it does get a little bit trippy. And let's recap horizontal shift. So given a positive number, if we subtract the positive on the inside, that's going to be the original graph shifted c units to the right. If we add a positive on the inside, that's going to be the original function shifted c units to the left, right? So horizontal change, reverse of our intuition. Okay. So that covers six. That covers 6 of our transformations. I think I'm going to piggyback off of my prepared notes here. Can anybody identify what is the base function here? What's our parent function? Right? What's our parent function here? I think in our first example, the parent function was absolute value, right? So from our library of functions, what's the parent function here? Square root function, right? In our previous example, I think we started with absolute value. The second example, the parent function was squared function. So this one, the parent function is the square root of x. Can anybody describe the generic shape of a square root function? Like how do you remember the shape of the square root function? Can anybody describe that? I'm just curious. Going once, going twice. It looks like a V. No, the V would be absolute value. That's okay. Okay. So the way I like to remember the square root function, the general shape of it with like manipulations, half of a parabola going, yeah, right? That's essentially what I was about to say. Yeah, that's exactly it, right? So the general shape of a square root function is going to be the top half of a sideways parabola. So if you think of a parabola, a U-shaped curve, you turn it to the right and cut it in half, like horizontally, then square root function is going to be the top half of a sideways parabola. Okay. So if our parent function is the top half of a sideways parabola.
Good morning. Can I get eggs and hash browns?
I'll at least mute everybody. I got it. No, it's no worries. Yeah, as long as you just let me know and I'll mute them. Yeah, so I am using my microphone today, so I can't hear you guys, but I am monitoring the chat. So but yeah. So with this guy, we're actually sketch the graph, right? So first we're going to start with our parent function, which is going to be square root of x. So then we have 2 manipulations going on here. We added 2 on the inside, and like just like in life, if you're trying to like grow or whatever, you don't necessarily have to do this, but this is just my preferred way of going about it in life. Now, in this is also what's recommended. If you do it in the wrong order, then it can throw off the final image. But the recommendation when we're doing multiple transformations in one equation is to work our way from the inside to the out. So start with the innermost nested set of parentheses, do that first, and then kind of work your way to the outside. All right. In life, like if we're trying to grow, I would personally recommend changing your inside, but so this society seems to put makeup on everything and not really get to the root of problems. And they like to be surface, which is great for like immediate gain, but in the long run, the root problem is still going to be there. So like if you don't address the root, it's just going to be this constant like struggle until once you can resolve the root of it, then the whole system will heal. So anyway, so that's just a personal philosophy, but it's to each his own. There are pros and cons of one versus the other. As far as this is concerned, the recommendation is when we're doing multiple transformations in one function, work your way from the inside to the out. All right. So we started with a base function of square root function. Now, if we say plus 2 on the inside, if it's an inside manipulation, is that going to cause a vertical change or a horizontal change? Right? I'm not going to do a poll. I thought about doing a poll, but I'm like, it's okay. There's no duty, right? inside manipulation. Inside manipulation, is that going to cause a horizontal change or a vertical change, right? But I would like some feedback. Uh, okay, so that +2 being on the inside is going to cause a horizontal change, right? That's correct. I saw it right before I said it. So then, which way? So if we think about the top half of a sideways parabola, if it's going to cause a horizontal change, is it going to move it 2 units to the right, or is it going to move it 2 units to the left? Remember, it's going to be the reverse of our intuition, right? So it should move it 2 units to the left, right? So I know there was a lot of back and forth as far as left and right because some of it was confirmation, some of it was directional. Who's on first? Yes is on first. No, who? That's what I'm asking you. That whole Abbott and Costello routine or whatever. Um, so we start with the top half of the sideways parabola. This is basically saying move it 2 units to the left, and then outside manipulations cause a vertical change. They follow our intuition, so we would anticipate it would go down by 3, right? So top half of a sideways parabola starting at the origin, we're just going to move it left 2 and down 3, and we're done. Right. So this is actually a sentence. This is painting a picture. This is saying start with the top half of a sideways parabola, at the origin, and then move it left 2 units and down 3 units, and you're done. Right. So I'm going to piggyback off of my prepared notes. I just wanted to kind of have that conversation. Right. So again, we're starting with the parent function of a square root function. They rewrote it, right? So instead of working it as x+2, they rewrote it as x minus a -2 because the form is really like x minus whatever. So then we can see that, oh, we moved it left 2 units and down 3 units, right? Whatever it kind of takes for it to sink in. Okay. So, and here's a pictorial representation. The black is where we started. The blue is where we moved it left 2 units. And then the red is where we moved it down 3 units. And the red is the final graph. All right. That's our final graph. All right. All right. So, hopefully we're all aboard and we're not all bored. I know this stuff can be kind of dry. Do you have dry and red eyes? Use clear eyes, man. I know that's a really, really ancient commercial. So that kind of like, I have not seen that commercial in like ages. Anyway, uh, okay. So that's how. So again, that's how we're using like transformations to like graph functions. And again, we've really talked about 6. I think we still need to officially go through reflections, right? So I think earlier we mentioned if we multiply the outside of our base function by a negative, so outside manipulations are only going to affect the y value. It's like our y values are going from positive y to negative y. So it's going to flip vertically over the x-axis, okay? So multiplying the outside of our base function is going to flip our original graph vertically over the x-axis, okay? Right? So here's a pictorial representation. Like if the blue is our original function, and we multiply the outside by a negative, the x values all stay the same, but the y values go from positive y to negative y. All right, so it flips vertically over the x-axis. So the red would be the final graph. So then if multiplying the outside by a negative causes a vertical flip, then hopefully you could anticipate multiplying the inside by a negative would cause a horizontal flip. Okay, so multiplying the inside by a negative, the x values flip sign, so the x value goes from positive to negative or vice versa, but the y values are going to stay the same. Okay. So in this image, the blue is where we started. We multiplied the inside by a negative. Notice the y value stayed the same, but the blues went from positive to negative and vice versa. Okay. So explain how this graph can be obtained from the graph of the parent function absolute value of x. Okay, so our base function here is absolute value of x. I'll give you a hint. There are a total of 3 transformations at play here. Can anybody tell me the 3 transformations, how they affect the graph, and also describe them in the proper order? Like, so what's like, for instance, the first transformation is so and so. This affects the graph so and so, right? The next transformation is so and so. This is going to have this effect. The final transformation is so and so. It has this effect. Can anybody tell me those 3 in the proper order? And I'll give you another hint. The recommendation is to work your way from the inside to the out. So start with the innermost nested grouping and then work our way out. I'll just give you like a, just a little bit of time, right? Let me see if I can pull up my clock. Anybody like? Let's take at least 15 seconds, maybe 30 seconds. What's the time? Because we have less than 10 minutes left in class. Oh, man, oh man. So, well, just to fill the air, where I'll give people a chance to at least think about it, even if you don't answer. I want you to just take a moment to think about it. Sometimes I think about like if I started my own school, what what changes need to be made in order to strengthen people, right? Like, because personally, I don't agree with everybody taking math because everybody doesn't need it. They just need to know how to use it, and when they don't know how to use it, then they can come to somebody like me and pay, right, and just pay for me to do it for them, right? Which is what happens anyway. But I'd rather have people just focus on whatever they want to focus on. You know what I mean? Okay, okay, we got a result. Let me see. So the -2 shift the function right 2 units. I can agree with that. The negative reflects the function across the y-axis. Oh, I think you missed something there. The +3 shifts the function up unit. Okay, so you would have gotten like I would have passed. That would be a passing answer. Notice that the negative is outside our base function, which should cause a vertical change. It should flip it vertically over the. So instead of y-axis, it would flip across the x-axis. It would flip it top to bottom instead of side to side. Aside from that, that was fantastic. You know, even the error was fantastic because that was an opportunity for us to grow together, right? So, like the beautiful thing about getting things wrong is that as long as you learn from it and you're not constantly making it repeating the same mistakes, that's the beauty of it, right? But when we procrastinate and we wait until the critical moment, like we get on an exam or a proctored exam or a job interview, and that's when we need it. If you procrastinate and you wait to a critical moment to start making your mistakes, then that's going to be more devastating. Versus if you do your homework and you get past your mistakes early, then when you need the information, it's going to be in your psyche, and you're gonna be able to access it, right? So hopefully that made sense. But that was a really great articulate because that's exactly what's going on, right? Like he said that he started with the -2. I agree. That's the innermost nested manipulation. -2. So we're starting with the V, and we're going to kind of track the vertex. It should move it right 2 units, and then instead of flipping horizontally, we're going to flip it vertically. So we're going to flip it top to bottom, and then go up 3. So again, manipulations. We're starting with a V with the vertex at the origin. We're going right 2, flipping it top to bottom, and then up 3, and that's our final graph, right? Okay. See the clock, we got a solid 5 minutes, right? A V at the vertex with the vertex at the origin. We went right 2 units, and then we flipped it vertically. So the X value stayed the same, but the Y's went from positive Y to negative Y. And then we went up 3. That was awesome. All right. That was awesome. So that kind of brings us to those 6 transformations. We still have 4 more, and we got like 5 minutes. So let's kind of go on forward. So, okay. So now here, we're going back to the parent function of absolute value of x. With g, notice we're multiplying the outside by a number larger than 1. And with h, we're multiplying the outside by a number between 0 and 1. So a number that's less than 1. We wouldn't really do this as multiplying by a number less than 1 because then that would include negatives. Then we're getting into the previous part with flipping, right? So usually we talk about it either as multiplying the outside by a number larger than 1 or multiplying the outside by a number between 0 and 1, right? So we want to see, how does multiplying the outside by a number larger than 1 affect the graph? How does multiplying the outside by a number between 0 and 1 affect the graph, right? So we chose several values of x. Absolute value, you know how to crunch that number. And then for g, whatever results we get, we're going to multiply those results by 2. For h, whatever results we get from f, we're going to multiply those results by half, okay? So you know how to fill in this chart. We're going to piggyback off our prepared notes, okay? So the blue is the original. Notice that when we multiplied the outside by a number larger than 1, it stretched it vertically, right? It kind of got more tall and skinny, but it got bigger vertically. So multiplying the outside by a number larger than one cause it to stretch vertically. Multiplying by the outside by a number between 0 and 1 cause it to compress or shrink vertically. It got smushed vertically, right? Low and wide. Okay. So that brings us to, well, we kind of just described that already. So then if we, now we want to consider multiplying the outside by a number. Let me see, where is it? So if we multiply the outside of our base function by a number larger than 1, it's going to cause a vertical stretch. If we multiply the outside of our base function by a number between 0 and 1, it's going to cause a vertical compression. Okay. That's the gist there. I'm trying to go through. So then we looked at the two where we multiplied the outside of our base function. Now we want to look at multiplying the inside of our base function. So as a recap, inside manipulations generally cause a horizontal change and the reverse of our intuition. So if we multiply the inside by a number larger than 1, it's going to cause a horizontal change, but instead of stretching horizontally, we would anticipate it to compress horizontally. It's the reverse of our intuition, right? So multiplying by a number larger than 1 on the inside should cause a horizontal compression by a factor of whatever that number is, right? So that's number 2. If we multiply the inside by a number larger than 1, it causes a horizontal compression towards the y-axis by that factor of whatever that number is. If we multiply the inside by a number by a number between 0 and 1, it causes a horizontal stretch by a factor of whatever that number is, right? Again, it's the reverse of our intuition. So, and I think that brings us to all 10 transformations. The first 4 were rigid transformations. It moved it either up, down, or side to side. The next 2, I think, were also rigid transformation. It either flipped it vertically or flipped it horizontally. And then the last 4 we call are non-rigid transformations or distortions. It's going to stretch it either vertically, compress it vertically, or it's going to stretch it horizontally or compress it horizontally. So those are the 10 transformations that we're trying to process. Each transformation in and of itself is simple, but altogether it can be information overload, right? So again, the best way to combat information overload is to give yourself as much time as possible. Do not procrastinate so that you make your first mistake on the exam. You want to get past your mistakes now as early as possible. So that way, later down the line, when you need this information, whether it's for this course or a proctored exam for something else or for a job interview, when you need it, you're going to have access to it. But if you kind of don't do it or don't process it, when you need it, that's when you're going to start making your mistakes at the critical moment, right? The goal is to get past the mistakes as early as possible so that when we need it, we've already processed it. We know how to use it, right? Okay. I'm going to have to leave these as exercises because we're kind of out of time. If you want to see these, you know the details are in my recordings. All right, here's another example where we're doing multiple transformations in one go. I'm going to have to leave this as an exercise. Okay. All right. All right. That wasn't too terribly bad. So we made it. Are there any burning questions before we go our separate ways? Let me kind of check over here. I know you guys are okay. I've been using it. Do I see any direct messages? I know those don't show. Okay. So you guys are looking good. Let me just go ahead and make a copy of this available. Share. Right here. Okay. Fall, traditional, Algebra 1, notes, updated daily. Okay. So when this window closes out, you'll receive a copy. I don't think I wrote anything today, but everything is worked out and we had the conversation. So anything that you saw on the screen as far as the PowerPoint lecture slides, you'll be able to access. Again, check your grades in Blackboard for accuracy. As long as like the scores that you're getting on My Math Lab are showing up in Blackboard, that's the main thing. It's not going to be 100% accurate until we get to the end of the semester. So, as long as those grades are showing up properly, that's the main thing. If you notice that anything is missing or out of order, then just bring it to my attention. Text me, call me, email me. and then I will make sure to resolve it. Are there any burning? I'm going to go ahead and remove my microphone. Are there any burning questions before we go our separate ways? I'll remove the microphone in just a moment. If there aren't, going once, going twice. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening. And we'll meet back on Wednesday to go through as many of the corresponding homework questions together as we can. All right, gentlemen, take care. I'm removing my microphone now. And until next time, take care. Peace.
Question.
Yeah, go ahead.
When is our midterm, or is it do we just have an exam? I wasn't I wasn't.
Yeah, okay. We don't have an official midterm exam. What is it time for midterm grades to be due or something?
Yeah, this week is like midterm week.
Okay, yeah. So we don't really have a midterm exam. It's just based on whatever we've done. So I did just update grades. I
Okay.
guess I can. So check your grades in Blackboard for accuracy. Um, some of the things we're not porting. It's supposed to be an automatic like live grade update. So like when you finish an assignment in Blackboard, it's supposed to update automatically. Some of them were not porting, so that's why I keep encouraging you all to like check it for accuracy. And I'll just be sure to submit midterm grades. But the midterm grade is just based on whatever's been due. So basically, weeks 1 through 5.
Thank you.
Uh-huh. Any other burning questions, gentlemen, before we go separate ways? Going once, going twice. All right, gentlemen. Enjoy your evening, and we'll meet back on Wednesday, same time, same place. Take care. Peace. Chat.